Hello everyone, and thank you for tuning into my video, Understanding Systems of Three-Dimensional Equations. To better understand a system of three-dimensional equations, let's first take a look at two-dimensional systems. In algebra, most of what we do involves working with two variables, x and y, on a rectangular coordinate plane. A regular system of equations with only two variables describes how one-dimensional objects, in this case lines, interact on this two-dimensional coordinate plane. By adding in a third variable called z into our system, we increase the dimensions of both the objects and the coordinates. Therefore, a system of three-dimensional equations describes the interactions of two-dimensional objects, also known as planes, on a three-dimensional coordinate system. The importance of working with three dimensions is that we can describe the motion of objects in our world within three dimensions, since we live and move in three-dimensional space. Now, this new concept of three-dimensional systems can be a little tough to grasp at first, so let's consider the following illustration. Suppose we are walking along, and we happen to stumble across a shoebox, or really any type of box for that matter. Point to any one of the corners on that box, and you will see that that point is formed at the intersection of three sides of the box. Each side of the box represents a two-dimensional plane, which again can be described with a three-variable equation, and the point of intersection of these three sides represents the solution to this system of three-dimensional equations. As a final note to this discussion on three-dimensional equations, it's worth noting that the types of solutions for three-dimensional equations are similar to those of two-dimensional equations: no solution, one solution, or infinitely many solutions. A system with no solution indicates that there is no distinct point at which all of the objects intersect. Two parallel lines, for instance, would indicate that a system with two equations has no intersecting point. A system with one solution indicates that there is exactly one point at which all of the objects intersect. We saw earlier how the shoebox example illustrated a system of three equations with exactly one intersection point. Finally, a system with infinitely many solutions would indicate that the number of points of intersection is infinite. This occurs when the objects of the system form some kind of overlap. The only possible type of overlap for a system of two equations is a one-dimensional line, whereas with a system of three equations, there are two possible types of overlap, either a one-dimensional line or a two-dimensional plane, depending on the system itself. Well, that's all the time I have for now. I hope this video was informative and that you have a better understanding of systems of three-dimensional equations. Thank you for watching.